So we have a box, a crate, we are told, of books being moved by a student. They are pulling with an applied force of 90 newtons at 30 degrees above the horizontal. And the box has a mass of 20 kilograms. So this is mg, this is 20 kilograms times gravity. This is sample 4D. So we're going to do we did sample 4C, we're going to do sample 4D also. Coefficient of static friction or kinetic friction between the bottom of the box and the sidewalk is 0.5. That's pretty high. That's rough sledding. Find the acceleration of the box. So do you see where these do start to get a little bit hairier? All right.
Oh wait, they're just starting this.
I think they were hairy since like 2 days.
Nah.
We're at like 6 feet.
This is full fuzz here. Okay. This is we've got Bigfoot in terms of hairiness. Okay, we're up to Sasquatch. We're gonna see if we can't give Sasquatch a haircut. All right. So first off, let's ask this question: is the box rising up into the air or sinking into the sidewalk? No. Sum of forces. Good job. Sum of forces on the y, therefore, is 0. Boom. Okay, so we're dealing with the x. So let's talk about this applied force on the x. Can you create an expression for that?
Yeah.
Which is?
30 cosine force applied.
Yes. Cosine of 30 times the applied force. All right. So cosine of 30 times 90 newtons. So we've got our applied force, we've got our force of gravity. Is there any applied force on the y-axis? There most certainly is. So this is force applied x. Force applied on the y, can you create an expression for that?
90 sine 30.
Yep. Sine of 30 times 90 newtons. Okay. Why do we need to know the force applied y? Why? What were we not given here?
Force the natural.
Did you just have a light bulb moment?
Yep.
Okay.
Natural. The natural.
Do we have the kinetic force here? Do we have the force kinetic friction here?
Yeah.
No, we're not given that. But yeah, we want to know the box's acceleration. If we want to know the box's acceleration, we have to work backwards to net force. Let's set up the overall problem for what we're looking at. So we would like to know net force. Or I'm sorry, this. Well, we have the mass. We need to be able to find the net force. So in this case, and we're dealing with all, it's going to be sum of forces on the x. What are our forces on the x-axis? We got 2. We have what? F applied on the x minus f of k. Okay, do we have f of k? No. And this whole thing is equal to mass times net acceleration. So here's what we're working with. So let's draw that over here. F applied on the x minus f of k equals mass times net acceleration. Do we have an expression for f sub k? Sure do. Mu k equals Fk over Fn. Wunderbar. Can we create then mu k Fn equals Fk? Okay, so now we're up to force applied X minus mu K Fn equals ma net. Do we have Fn? No! All right, back to our side expressions. So sum of forces on the y equals Fg minus Fn minus F applied y equals 0. Fg minus F applied y equals Fn. Okay. That logical? That works? Everybody's okay with this? You want to follow each step carefully. So we created this expression for F sub k, for force of kinetic friction. We need an expression for F sub n, our normal force, and we get it from our sum of forces on the y. So now what we have is force applied X minus UK times F sub G minus force applied on the Y, because we inserted this expression, is equal to the mass times the net acceleration. Can we solve, is everything there now something we've got?
Yes.
Yes. Can we solve for net acceleration now? Yes. So now it's just a matter of algebra. Divide both sides by m, plug, and go. So these are not hard. They're just complex. They're layered. The nice thing is that all these forces have relationships. Okay, do we want to go ahead and do you want to do the math on this, or do you want to just leave it conceptual? Okay, because we're kind of out of space. Do you see how you plug in all these nesting expressions? And it's the same thing that you've done with kinematics. It's the same thing you've done with other stuff in physics. So you're just creating expressions. Every time you've got an expression, you look at it and go, do I have all this stuff? Oh, no. Can I create an expression for that? Oh, yeah. Do I have all this stuff? Oh, no. Can I create an expression for that? Oh, yeah. So just asking yourself at each step, each point in the game.